Okay. Well, hello. Go ahead and introduce Arnold. Okay. Introduce Arnold.
Thank you, Tom, and hello, everyone, and welcome to the sky this month. We'll look at the stargazing highlights for the next 5 weeks from tonight to 6 January before our next monthly meeting. The night sky will be depicted as seen from Toronto. As for the highlights, the first is tonight with a close encounter of the Pleiades and the moon. Tomorrow we have a full supermoon. This coming Sunday morning, you can catch Mercury at its greatest elongation west of the sun. A week from tonight, Regulus and the moon get close and personal. The Geminids peak on Saturday, the 13th, and the following morning, Spica trails the moon by 3 degrees as they rise. On the 18th, in morning twilight, the moon rises 6.7 degrees south of Mercury. The winter solstice occurs on the 21st, and the Ursids peak the next morning. The moon occults Lambda Aquarii after Christmas dinner. In the morning of the 31st, the moon leads the Pleiades by 3 degrees as they set. On Saturday, the 3rd of January, the Quadrantids peak. Unfortunately, the moon will be super full again that night. On Tuesday night, 6 January, the moon lags 6 degrees behind Regulus as they rise. In addition, we have a returning comet that should brighten up nicely this coming month. We've got something to look forward to each week, so whenever we get a clear night, there will be something like meteor showers, a comet or four, occultations or close encounters with the moon, and of course, deep space with the longest nights of the year to observe or image them. The observing window is basically 12 and a half hours long, and night is 11 and a half hours during this period. You'll notice there's no difference in their durations between tonight and Jan 6, although their start and end times are all 16 minutes later. Maybe you can notice a slight shift to the right in this nighttime bulge in the sky, Stargazer's Almanac hourglass that would account for that extra quarter-hour shift or drift to the later time. Now, there are two full moons occurring during this period I'm covering. The full cold moon of December is also known as the long night moon, the drift moon, the frost exploding trees moon, the snow moon, the winter maker moon, and the oak moon. Meanwhile, the full wolf moon of January is also referred to as the center moon, frost exploding moon, freeze up moon, severe moon, Canada goose moon, spirit moon, and moon after Yule. The exploding trees in December and January refer to sap expanding in extreme cold and causing loud cracking of branches or trunks. Now, in between, new moon, what I like to call no moon, falls on the 20th, which is on a weekend. Many of the sky scenes I'll be showing are on or around the 20th. So let's begin our tour of the night sky with a look at the planets, starting with the inner solar system. As of tonight, Mars is less than 10 degrees east of the sun, and as Earth orbits around the sun more quickly, we're putting the sun in between us, so Mars is basically a no-show now and for the next 6 months, actually. Venus is east of the sun and even closer to it, rising in bright twilight. Speeding around the sun faster than we can chase it, the hot planet will dive behind the sun this month. On the 7th of December, Mercury reaches greatest elongation west of the Sun at 20.7 degrees. And for the next 4 weeks, the elongations for Mercury, Venus, and Mars all shrink, making Mercury the only inner planet that we might be able to spot just before it's lost in the sunrise. Venus will be hiding behind the Sun on January 6th, with Mars following 3 days later. Tomorrow morning, Mercury is already a difficult catch, and it's diving down to pass in front of the Sun on the 20th. And here's an optimistic suggestion how the gibbous Mercury might look if you can push your telescope to 100x, and the seeing and the transparency and everything is perfect, working in your favor. You might be able to do that. Venus is diving behind the Sun, but you can catch it before sunrise when the Sun is a couple of degrees below the horizon. But once you spot it, don't linger. The Sun will soon rise. And this close to superior conjunction, Venus appears circular, 99% illuminated. Now, if you can photograph Venus now, you'll be able to repeat Galileo's observations of the planet's phases and changes in apparent size that he did back in 1610. You can do that by taking photos of Venus on or near these dates in 2026. These phases, in step with the change in Venus's size, convinced Galileo that Venus was orbiting the Sun, not the other way around. Be sure to use the same camera and lens to capture the change in Venus's size. And if you miss tomorrow, you'll have another chance with Venus at 99% on the 8th of February. Mars is also diving towards the Sun to pass behind it on 9 January, and is too close to the Sun to be observed. It's too tiny to see anything anyway. It's about as far from Earth as it ever gets, 20 light minutes away. The red planet will return to our morning sky in July. All 4 of the gas and ice giants will be available for observing as soon as the sky darkens this month. You won't have to wait for any of them to rise. By the first week of January, Jupiter will rule the night sky, just 3 days shy of opposition. Uranus is next, planet to the west, available for most of the night, and Saturn and Neptune remain very close companions in our night sky. Just 3 degrees of elongation difference between them. They will be the first to set, minutes apart, around midnight. You'll have no trouble finding Jupiter hanging out with Pollux of the Gemini twins. By the 20th, Jupiter is shining around magnitude negative 2.3 when you factor in our atmosphere. Jupiter is currently in retrograde motion. It started a couple of weeks ago and will end in late March 2026, with opposition occurring halfway on January the 10th, about 6 weeks from now. Any size telescope can show you the equatorial belts and the 4 Galilean moons. And light blue or light green filters will darken the rusty colored cloud belts and the giant red spot, making them easier to see. Maybe it's a good idea for a stocking stuffer. Starting on Tuesday night, 15 December, around 8:30 p.m. and running to 3:08 the following morning, the Galilean moons Europa and Callisto play peekaboo with Jupiter's shadow, or by hiding behind the planet and reappearing. What makes these events so interesting is that Io, the closest to Jupiter and the fastest of the 4 Galilean moons, is the moon most likely to participate in transits and shadow transits and occultations, but is actually taking a break and not participating. Callisto is just the opposite. It's the furthest out and slowest moving of the 4 moons and least likely to be involved in transits or occultations, yet is the most involved in this peekaboo game. Meanwhile, Ganymede down here, he's disinterested and is off on his own. So let's roll the clip and see what happens. Within 43 minutes of each other, Europa and Callisto disappear into thin space as they hide in Jupiter's shadow. Jupiter looks odd with only 2 of its big moons showing. A few minutes after midnight, Ganymede and Io appear equidistant from Jupiter. Interesting sight. Now, around 1 o'clock Wednesday morning, Europa reappears from behind Jupiter and Callisto slides out from Jupiter's shadow. Around 1:30, there is a nice Kodak moment as all 4 of the moons pose symmetrically, perfectly symmetrical around Jupiter, looking like a family portrait. Now, if you are stargazing at 3 a.m., you can watch Callisto go behind Jupiter, leaving us with only 3 moons the rest of the morning. You can find Uranus 4 degrees southeast of the Pleiades. If you are able to see Uranus without optical aid at around magnitude 5.8, it will be the only point of light you will notice to the southeast of the Pleiades. There's no star brighter than Uranus in close proximity to the southeast of the Pleiades. So if you can see Uranus, that'll be the only dot in that area. For this stellarium view, I set the dimmest star to magnitude 5.8. Saturn and Neptune can be found near each other in the southwest after nightfall. Saturn's magnitude 1 golden dot is 6 degrees below Lambda Piscium. As we saw earlier, you'll find Neptune just a few degrees from Saturn. Saturn's retrograde motion, which began in mid-July, has just ended back on November 27. Saturn has begun to drift westward against the background stars. We can still catch Saturn due south as it crosses the meridian around 6 p.m., and both planets will set around midnight, minutes apart. Saturn's rings remain very thin, widening ever so slightly from just 1/3 of a degree last month to 2/3 in December. So the rings remain very hard to see while making its moons easier. Although the rings are too narrow to benefit from colored filters, a greenish or greenish yellow filter may help with the cloud bands. With your telescope aimed at Saturn, you can find Neptune by slewing 3.1 degrees east, then 2.4 degrees north. Last month, Neptune was found around halfway along a line connecting a pair of magnitude 9 stars. Well, this month, Neptune is east of the line. Like Saturn, Neptune had been in retrograde motion up until just a few days ago, so it had drifted east of the line since November. As for comets, short-period comet 24P Shomas is making its return this winter. It has an orbital period of 8 years and 2 months. It will cruise east through the zodiac, out the body of Leo, and right through the Virgo cluster. Since 1950, the comet has usually reached or exceeded magnitude 10, and is predicted to reach magnitude 9 on this pass. Recent magnitude measurements appear to agree with the prediction. Now, perigee and perihelion are only 4 days apart in the first week of January. It will be an easy target in any telescope and increasingly easy in binoculars as it passes and brightens beyond magnitude 10. You may want to check it out in the morning of the 26th of December when the comet pays a visit with a number of galaxies, notably M100 and NGC 4312. Now, I'm not sure if the comet will be just a round coma as suggested here, or if it will grow a tail. So it would be fun to check it out. That's the 26th in the morning. Comet C 2025 R2 Swan continues to cruise through Pisces. its light curve is in a steady decline. And if it holds up between magnitudes 11 and 12, you might be able to observe it in a telescope around 8 to 10 inches, 200 to 250 millimeters. Comet C2025 R2 Swan and C2025 K1 Atlas continue to be well positioned for observing this month, maintaining good separation from the horizon. But will they be bright enough? By the end of November, both comets were heading down to magnitude 11, so they should still be visible to start December. R2 Swan might be easier than K1 Atlas. R2 Swan is a long period comet with high orbital eccentricity of 0.9941, resulting in an orbit like a stretched rubber band, taking 793 years to orbit. K1 Atlas will become interstellar, just. Its eccentricity is barely over 1 at 1.0015. So its orbit is hyperbolic and it will escape our solar system. In fact, it will escape in pieces. In mid-November, Gianluca Massi of the Virtual Telescope Project imaged the comet, revealing it was split into 3 or more pieces during its close encounter with the Sun on October 8. Comet 3I Atlas also remains well above the horizon throughout December. 3I means third interstellar visitor, and this visitor is twice as old as our solar system. It's estimated to be 7 billion years old, possibly billions more. According to astronomers Astor Taylor, University of Michigan, and Daryl Seligman at Michigan State, these objects most likely formed in protoplanetary disks alongside exoplanets and were subsequently ejected via planet scattering or post-main sequence mass loss. So it would be pristine if it never visited its home system star. The comet should hopefully still be within reach of 8 or 10 inch or larger telescopes while it remains around magnitude 12. The peak for this year's Geminids occurs on a weekend, Saturday into Sunday, 13 and 14 December, when a waning crescent moon rises around 2:30 in the morning. The Geminids have a broad peak lasting over 24 hours, making them dependable, which means if you catch it on either night, chances are you will see some because the stream is broad enough to cover more than one night. And it will boast a zenith hourly rate of 150, so I guess it's reasonable to expect one a minute. The radiant in Gemini will be 6 degrees above the horizon and rising at the onset of night, 8 hours before moonrise. Early meteors will streak across our atmosphere at a shallow angle, but they won't leave long trails because the meteorites from the rocky asteroid Phaethon hit our atmosphere at 35 kilometers a second, which is medium slow for meteors, but that makes them easier to spot. The peak will intensify just as the moon is rising, but hopefully they will still stand out because they are bright, and that's because its rocky meteoroids are up to 10 times the size of cometary particles and weigh 2 to 3 grams per cubic centimeter, up to 10 times denser than cometary dust at 0.3 grams per cc. So the Geminids carry more of a punch. That enables them to penetrate deeper into Earth's atmosphere and produce brighter, more persistent fireballs compared to softer cometary particles. Because the Geminid meteors are rocky in nature, they contain material not normally released by icy comets. Comets release silicates, which produce white meteors, whereas the rocky bits of the Geminids result in brightly colored meteors. Yellow signifies iron, violet indicates calcium, orange denotes sodium, and blue-green means magnesium. And if you see red, That's nitrogen and oxygen atoms in the atmosphere glowing as they are superheated by rocky bits hitting them at 35 kilometers a second. In this award-winning photograph by Frank Kuzaz, we see traces of magnesium and calcium and superheated oxygen or nitrogen drifting away. Now, Frank was intending to shoot a galaxy, but accidentally forgot to zoom in just as he took this picture as the Geminid meteor zipped by. Good timing. The Geminid stream of sand-sized particles is very narrow, indicating it has not had time to spread out like others. Astronomers believe the trail is less than 2,000 years old. The Ursids have a very narrow stream. The shower is active for only 9 days, peaking in the middle for just 2 hours, beginning around 6 a.m. on Monday, 22 of December. When the sun is 18 below the horizon, it's the very end of night. So you should be able to see some of these before astronomical twilight brightens too much. The Quadrantids are the only other meteor shower with an asteroid presumed to be its parent. The shower was so named because its radiant lies in the former constellation Quadrans Muralis, created by French astronomer Jérôme Lalande in 1795 in honor of the quadrant that he used to map the stars. He'd hang the quadrant on the wall when not using it, hence the Muralis. The constellation was dropped in 1922 when the IAU convened for the first time in Brussels and established the 88 constellations we use today, like Boötes. The Quadrantids is considered a reliable shower with the potential of ZHR of 100 during its peak. Unfortunately, the peak is short, lasting just 2 hours, expected to start at 4 p.m. on Sunday, the 3rd of January, with the sun still up for another hour and a supermoon about to rise. So good luck with this one. Moving on to the sun, it dips to its lowest at noontime on the 22nd of December, marking the winter solstice and the longest night of the year. By 6 January, the sun has climbed back to almost the same as today. I hope you like the long nights the sun is giving us this month. Persistent auroras over the high latitudes over the past 2 weeks were the result of large Earth-facing coronal holes that allow streams of charged particles, the solar wind, to escape unimpeded. Coronal holes around the sun's equator are a classic sign of a weakening solar cycle. So cycle 25 may be weakening, but it's still very active. Videos captured by LASCO C2 and C3 cameras on board the SOHO spacecraft reveal large eruptions shooting into space from the far side of the sun. These solar storms are coming off from regions that were active and hitting us with strong CMEs last month before they rotated out of view. They are still active and are about to return again, setting up the likelihood of more geomagnetic storms here on Earth, producing auroras and disrupting daytime radio frequencies used by dispatch and first responders, and it's also increasing radiation for airline crew and passengers. The Stereo A spacecraft that orbits the sun is currently on Earth's side of the sun and cannot image the sun's far side. But with Mars now approaching solar conjunction, the Perseverance rover is in position to have a look. And it took this image of the sun's back with its Mastcam Z camera. You can see here some of the dark features, the dark markings, indicating active sunspot regions that were responsible for the big coronal mass ejections that we saw in the LASCO videos. That's amazing that we can do that. Now, before I let this slide run, as we talk about the moon, please note that this animation of the moon ends on the 31st of December. NASA's Visualization Studio has not uploaded the 2026 version yet, so I won't have any visuals to show you for the January events. But let's play what I do have now for the moon this month. It will be full tomorrow night, and that coincides with perigee making this a supermoon, the third of 4 consecutive supermoons. January's full moon will therefore be the 4th and last one in this series. The last quarter is on the 11th. And the receding moon reaches apogee on the 17th. New moon is 3 nights later on Saturday, the 20th of December. As the moon heads back towards us, it reaches first quarter on 27th of December. On New Year's, the moon reaches perigee again, not quite as close as last time. Then it reaches full moon and a supermoon 2 nights later. It will have retreated just 1 degree, so it's considered super. And then it's a waning gibbous by the time we meet again in January. If you get a new telescope for Christmas, it would be fun for first light to observe the moon occulting Lambda Aquarii, one of the highlights mentioned at the top. Lambda Aquarii is an aging red giant, fusing hydrogen into helium in a series of shells surrounding its core of carbon and oxygen. On its way to becoming a white dwarf, its luminosity is 1,600 times that of our sun, making it visible at magnitude 3.7 at a distance of 365 light years. It's pulsating. It pulsates from 3.57 to 3.8 over irregular periods lasting from 24 to 50 days. The moon will be waxing, so the star will disappear behind the moon's dark limb. After the occultation, keep your telescope aimed at the moon and have a close look at crater Theophilus, where the solar elevation is 10 degrees. The crater is a candidate for earning your Explorer the Moon Observing certificate. Theophilus is an almost perfectly circular crater along the northwest coast of Mare Nectaris. It is 101 kilometers wide and has very high terraced walls. The flat floor is over 4 kilometers below the surrounding plains and is dominated by an imposing mountain with 4 peaks reaching as high as 1.4 kilometers above the floor. Shadows will help define the crater's rim and possibly reveal some of the terraces. The mountain's peaks will cast their shadows onto the floor, hinting at their heights. And besides totally covering up Lambda Aquarii, there are several other close encounters of the lunar kind this month. Maybe you caught it before tonight's meeting because the first close encounter is already underway. The moon rose just west of the Pleiades this evening, and we'll pay the Seven Sisters a visit tonight. By the time our meeting ends, the moon will have begun occulting the cluster stars. It will be difficult to actually watch the occultations with the moon being super full bright. A week tonight, the waning moon passes very close to Regulus. Whereas it is close for us in Toronto, the moon actually occults Regulus for our RASC Centre cousins in the blue shaded areas of this map, including Prince George, Edmonton, Calgary just above the line, Saskatoon, and St. John's also just above that line. For example, as seen from Calgary, The moon occults Regulus for 11 minutes late on the 9th. That's because it was just above the line, so the occultation is quick. While out enjoying the Leonid meteor shower on Sunday, 14 December, you can watch the moon rise very close to Spica. Maybe a meteor will shoot past. A very old moon rises south of Mercury 2 weeks from now on Thursday, the 18th of December. It'll rise somewhere in this area here. There it is. Look how thin the crescent is. You might need binoculars to help see that crescent. Venus will rise just ahead of the sun, and when it does, put those binoculars down because the sun's coming up right behind. If you're out and about in the wee hours of the last day of the year, you can catch the pretty sight of the waxing gibbous moon leading the Pleiades by 3 degrees as they set. On the night of 6 January, an old gibbous moon lags 6 degrees or 30 minutes behind Regulus as they rise. Regulus at 8:30, then the moon at 9. Did you notice the moon snacking on a bright star to its east as it rose? Let me play you this clip again. That's no ordinary star that the moon just gobbled up. That's Rho Leonis. It is visible to the unaided eye from an unbelievable distance of 5,719 light years, making it the second farthest star we can see by eye alone. The other one, as I recall, is almost impossible to see near magnitude 6, so for all intents and purposes, Rho Leonis is the brightest, furthest star the furthest star you can see with your eye. It's one of the brightest stars whose distance we cannot measure through the parallax method. It's a class B1 supergiant. Look at its position on the Hertzsprung-Russell diagram. It's right at the top. It has a surface temperature of 24,400 degrees Kelvin. Its luminosity is 165,000 times that of our sun. Yeah, I'd call that a monster. Its mass is 23 times the sun, which is way more than sufficient to go supernova. 8 times the sun's mass during main sequence is the threshold for going supernova. In fact, it's in the 20 to 25 times range needed to form a black hole when it eventually explodes as a type 2 supernova. It is 7 million years old, so it is at the end of its lifetime on the main sequence and is about to evolve into a red supergiant. That's an amazing star, worth thinking about as you watch the moon slip over it. Now, running from Capella to Pollux, then down to Sirius, Rigel, and then eventually Aldebaran. That is the winter hexagon filling the southeastern sky on the Saturday of the no-moon weekend. There are numerous deep space objects within the hexagon waiting for you to explore or image. Let's check out a few of them, starting with what feels like a must this month, the Christmas tree cluster. NGC 2264, the Christmas tree cluster, is easy to find. Its brightest member is 15 Monocerotis, another superluminous star. It's found 4 degrees south-southeast of Xi Geminorum, the southern foot of Pollux. 15 Montecerotis forms the trunk of the Christmas tree, while lines of 7th, 8th, and 9th magnitude stars outline the tree's shape. 15 Montecerotis is an amazing binary of 2 superluminous O and B class stars whose combined light shines at magnitude 4.68. They lie at a distance of 2,348 light years among 630 other O and B stars comprising the Monoceros OB1 association. There's an OB2 association on the western side of the unicorn. And with the camera, you can capture the famous cone emission nebula, whose gas is excited by the hot stars in the cluster. The cone shape looks like the wings of an angel perched on the top of the Christmas tree. Our next target is NGC 6169, also coined the 37 cluster. You can find it in the base of the Hunter's Club, less than 2 degrees from Xi and Nu Orionis, or just above the halfway point of a line connecting the head of Orion, Mesa, with Elhina, the north foot of Pollux. The arrangement of the cluster's brightest members suggests the number 37. And what this cluster may lack in quantity with only 30 members, it makes up in luminosity with a number of bright B and A-class stars in the cluster. Our next stop is in star-rich Auriga, where we have 3 quite different open clusters from the Messier catalog, M38, 36, and 37. M38 stars are loosely scattered and have a moderate brightness range among its 100 stars. It's fairly distant at 3,400 light years, and it's about 290 million years old. The cluster's brighter stars form the Greek letter pi. M36 shows more concentration, is a little more tightly packed, possibly because it is much younger at 25 million years old and hasn't had as much time to disperse. There is a wide range of brightness among its stars. The cluster has a few star chains that curve out, giving it the nickname the pinwheel cluster. M36 would be just as impressive as the Pleiades if it were as close. M37 is nothing like the other 2. It's the brightest of the 3, 75% brighter than M36, for example, and it's the youngest at 12 million years. The cluster is strongly concentrated, mimicking a globular cluster. In fact, it's more than 500 stars are so closely concentrated that they would be forever gravitationally bound to each other if it weren't for tidal interactions with our galaxy's nucleus on its eccentric orbit. So if it weren't for tidal interactions with the rest of the galaxy as it orbits around, it may never disperse. So what we have here are some 3 very different open clusters close together in Auriga for you to explore. I'd like to conclude with a selection from the Double Star Observer Certificate Program prepared by our beloved Blake Nancaro, who we unfortunately lost 2 years ago. In his memory, be sure to include a double star when you're stargazing. For example, here's a very interesting candidate from Blake's Double Star Observer Program. The candidate is Mintaka, the westernmost star in the belt of Orion. All 3 of the belt stars are O or B class double stars, but the double that you'll see in your telescope are not bound to each other. Instead, they are an optical double over 600 light years apart. The 2 components you'll see are Delta Orionis A, 600 light years away, and Delta Orionis C, less than 9 light years away from us. There is a B component, apparently, but it's too dim to be seen at magnitude 14. So I'm not sure why it would be called B. I thought they were lettered brightness. In any event, Delta Orionis A consists of a pair of orbiting massive stars, a top of the HR scale O star, and a nearly as hot B1 star locked in a tight 5.7-day orbit that can only be resolved spectroscopically. The pair are in a 152-year orbit with Delta Orionis AB, an almost O star, just one rung down at B0, the top of the B class. More about this AB star a little later. The C component consists of a pair on a 30-day orbit. CA is a B3 class star, and I couldn't find specs on CB in the SIMBAD database or anywhere else. The magnitude given for Delta Orionis C is that of the CA star, 6.8, which is a little too dim to see by eye, but it stands out easily beside the brighter Delta Orionis A, with a separation of 52 arc seconds, nearly an arc minute. If under high power the brighter A star appears a little bar-like, that would be the AB component extending the overall shape of the trio in one direction. And that's all I've got for tonight. Are there any questions?
Anyway, folks, are there any questions for Arnold? All right. Thanks again, Arnold, for a wonderful presentation. And our next speaker is Denis talking about the EM200, New Life for an Old Mount.
All right. Well, thanks very much, Tom. Appreciate the introduction. So tonight I'm going to do a little presentation on the EM200, New Life for an Old Mount. This has been a bit of a journey that I've been on over the past, I guess, almost a year and a half now. And it all starts with our asset management program. I'm going to tell you a little bit about what the EM200 is and what we know about it. Look at our initial assessment of it, talk about how a plan emerged here, and looking at sort of a before and after, and then hopefully we'll have some time for questions afterwards, and we can cover things off. So the first thing I wanted to sort of frame this with is our asset management program. So for people that aren't aware, we've been working for the past year and a half or so to identify things that have been donated to the center or things that we've purchased in the past, which are no longer things that we're able to use as a center or that are not being taken advantage of. Equipment that's not being used and just simply stored just gets older, doesn't get any starlight, doesn't get any use. So here's an example of one of the things that we managed to pass along to an enthusiastic user here. Was a SkyShed pod that was donated to the center. We didn't have any particular plans to use another SkyShed pod, and if we were to build another pad or observatory facility at the CAO, that would probably be several years in the future. So I'm very happy he came and picked it up December of last year, and we've put that money to work for other programs and services of the center. So we've been doing this for a number of things, and we'll talk about the success of that program during our financial report later on in this meeting. So the first time I met the EM200, I saw this mount sitting in the David Dunlap Observatory office when I was meeting up there with the team, Quinton and Phil. And what I noticed, first of all, was this beautiful mahogany tripod. Lovely. And an unusual tripod spreader that is a little bit of a different kind of thing. And I noticed, that it was from Takahashi. That was one of the things I noticed. And I also noticed that there was absolutely no way that one could put a telescope on it, because the top of the mount, as you can see, had nothing attached to it. So it's kind of like, oh, well, that's a bit odd. But what it was doing was it was taking up a lot of space at the DDO. So the office space that we rent there at the moment has a limited capacity for things, and it certainly wasn't helpful that we had this very large, heavy mount that was sitting there taking up a lot of floor space. Kind of, looked nice, but it wasn't really doing anything. So that was my first meeting with it, and we agreed that this wasn't being used at the DDO, and we took it away to try and see what we could learn about it and what we might do with it. So what is an EM200? So these mounts, I looked and researched, and I found this excellent summary on cloudy nights. And as you can read there, this is an old mount. It's been around for more than 25 years now. These were brought out in the late 90s, but they were very high quality when they were first manufactured. The goal here was to give a really great photography experience, and so they had built these mounts with very, very high tolerances, very high precision, but they didn't really have any serious electronics in those days. And what electronics they did have for them are basically no longer available, because Takahashi is still making telescopes, but they're no longer making mounts. Their electronic supplier is out of business due to COVID, and so we're really, there does not appear to be any kind of upgrade path for this kind of a mount today. Where did it come from was sort of one of the questions that I asked, and I didn't get a chance to do a lot of research, but it looks like it was donated to the center in the sometime in the 2000s. And we look at it, and it's one of the originals. The mount itself is the item, but the telescope that came with it was serial stamped with serial number 0013. So it was the 13th edition of that particular telescope that was manufactured. And the telescope, once we got it up to the Carr Observatory and we had a look at it, we realized that this mount was originally meant to go with a Takahashi telescope. So this is a 106 millimeters, about 5 inches, or 4 inches, or I should say f5, and it's a quadruplet fluorite apochromatic refractor. Doesn't that sound fantastic? There was a carrying case available. It's about 13 pounds, so it's a fairly heavy refractor compared to some, and there was some eyepieces with it. But one of the things that we learned about it was it had this enormous image circle, so 88 millimeters. And this is what it looks like. So again, looking at cloudy nights and seeing what they can tell us about these kinds of telescopes. So it's a Petzoval design that has sort of two elements, one at the front and another one right here near the back, which is why you see this plastic bag is over the end here. It's to try and protect the lens, because the lens is right underneath that little dot there that's the lock for the built-in rotator. And it's was a modified design, and it was really trying very hard to produce this perfect photographic flat field, 88 millimeters wide, high contrast, and no astigmatism. So it was a very, very nice telescope for its time, and it was, essentially for astrophotography of that time, it was felt to be a dream scope. So to understand this telescope in more detail, it's important that you have a look at the Takahashi's famous photo-visual system chart. So every one of their telescopes has one of these system charts. And what it does is it allows you to sort of see all of the different accessories that one could buy to convert the telescope from one purpose to other purposes. And you can see this chart from the 2001 is kind of grouped into 3 different families. So the visual family here shows that you have a specific adapter that you attach, and you can put a 1 1/4 inch eyepiece either straight through, or you can add a diagonal to see with a 1 1/4 inch eyepiece. You can also add a 2-inch eyepiece option if you wish. And then there's two other settings here. One is for DSLR or CCD imaging here. So this is an old style CCD camera and a DSLR camera. And then here is medium and large format cameras. So this was really the sweet spot of this telescope because it had that very large flat field. It could actually work with medium format and large format cameras that had film spaces that would be like 3 inches wide, which would allow you to capture enormous amounts of detail and handle blowing up quite well. So if you think of the posters that you used to see of Ansel Adams, he was taking all of those pictures with medium format film. So the Takahashi system as a whole allowed you to aspire to these kinds of photographic components. And it also included a built-in field rotator, something that you would pay extra for these days. It was built right in back in 25 years ago. But the equipment that we found for it was strictly visual. So the person that donated this telescope to the center had never actually planned or had ever actually gotten around to using it photographically, even though it was very obviously meant as a photographic mount. And while we were casting around, we found the clamshell for the EM200 mount. So we could actually put this telescope onto that mount. So what did we assess here at the end? So we looked in, we did our research. We certainly noted that it was taking up a lot of space in the DDO and it couldn't be used. There was no rings, there was no mounting plate. We took it up to the CAO, we did some inspection, we tried to connect it with the telescope, and we turned it on, we plugged it in, and we found that while the tracking motor was working, the hand box that you would use to control things with was not working. And the electronics, as we learned earlier, were basically obsolete and difficult, impossible to source. So in the end, we basically are saying, well, this is just one of the nicest looking boat anchors that we've ever seen. You drop that down, it'll certainly take care of anything up to about a 12-inch boat and keep it steady in one place. So that was where we left off. So stepping back another step further, well, we didn't want to just throw it out because it was an asset. It was donated in good faith to the center. We assumed that whoever donated it to us originally would want us to do something good with it. So we wanted to try and sell the scope and the mount for a reasonable amount of money. I could probably sell the scope without the mount easily because the scope itself is a very nice telescope and it's got a lot of fans out there in terms of that. However, then I'm stuck with the mount. So that's not an ideal situation. But the mount does not work. The motors were tracking only. And really, these days, 25 years later, we really expect auto-guiding and go-to to be an important part of any mount that you're using. And so this didn't seem to fit the bill. So we needed new motors. We needed some kind of a controller. And ideally, rather than just offering the clamshell, it would be nice if we could also offer the ability to put other telescopes on this mount, which would mean a dovetail platform of some kind that would work with Vixen and Los Mandy. So we took the motor out, and we had a good look at it here, and you can see that the drive section is kind of unique among mounts that I've seen. So basically there's these two worm gears here that you see at the bottom near number 4, and each one of those gears connects to a drive axis. So this one connects to the deck axis, and this one connects to the RA axis. The RA axis has a gearbox in the middle. This is number 3. And the purpose of that is to slow it down and to allow for precise guiding corrections on RA. So when this was originally designed, it was meant to be used photographically, and you would be using the hand box to do the guiding corrections because this was sort of before auto guiding was evolved. And so this was an important part of that overall mount. And so again, I reached out to my friend at Astro Gadget, who is the Ukrainian-based supplier of telescope mount upgrades and has a site, astrogadget.net. And he helped us to successfully reanimate a Los Mandy GM8. So I reached out to him and I explained the problem and I said, can we fix that? And he said, yeah, you can fix that. Here's what you would need to do. And as I chatted with him over the email, I learned he's originally from Kharkiv, and he's had to move to the Western Ukraine due to the war, but he's still living there, still pursuing astronomy as a hobby, even though his observatory is now in a neutral zone between Russia and Ukraine, and gosh knows it's probably been blown up by now. But anyway, he was able to provide us with a plan. So the prescription was, first, we need to get some new stepper motors. We need the motors that were originally included with the mount were just designed for tracking and for a little bit of guiding, manual guiding. So if we wanted it to be a go-to capable mount, we needed higher torque and amperage to really allow us to move the mount around. We also needed a new control box, which would be the control box that we would get from the fellow in Ukraine. And so the Pro version of this is designed for larger mounts, can handle up to 5 amps, and the power supply can take up to 28 volts with a maximum current of 2.5 amps. So this allows us to really push this large mount around. And it has, smooth acceleration and braking of the motors. We can handle a wide range of ratios for the gears. And the Wi-Fi and the USB pieces are built in, which is really, really useful and important. So one of the key things that the EQ Star Pro can help us with is this notion that we're able to change the key settings. So the gear ratio, the go-to speed, how much current is it allowed to draw up to a maximum, and as well as the acceleration. So you can see here, these settings are configurable at the firmware level. And using these configuration settings, we can adapt the controller to fit the mount. Most times when you buy an aftermarket controller of some kind, you're buying an aftermarket controller that fits a specific mount. Here we have a mount that, while it's very high quality and it looks really nice, there were probably only 50 or 100 of them ever manufactured. So nobody's going to give us an off-the-shelf solution for this kind of a mount. It's very, very unique. And it's also, interesting because if somebody was building, a completely custom or some other kind of do-it-yourself project that needed a mount, this software and this solution could be helpful as well. So the project then became this. First we have to get some motors. So I go to stepperonline.com. Of course, there's a stepperonline.com, and we order 2 compatible motors. We get the kit for the EQ Star Pro, and then we need to mount the new motors on the base plate, which is where we ran into another bit of a hurdle here. So we had a classic square peg round hole kind of problem. So the first problem we noticed was that the old motors attached from the bottom, from the top. So they had long screws that you would screw down to attach the motors to the base plate. So if we were looking at our thing here, these screws here, you're screwing from the top and they're going through and attaching to the base plate. So that was the first problem we ran into. And then the second problem we ran into was that the new motors both have 1/4-inch shafts. And the original motors had, one of them was 1/4 inch, but the other one on the deck axis was 1/8 inch. So it was actually smaller. So they had 2 different sizes of shaft, which meant there was 2 different holes in the mounting plate, which also meant that we had to expand the hole for the gear itself. So all of this involves figuring out how do we get around this. And the key task here was to create a new base plate that would both fit into the mount, so it had to replace the old gearbox, and ensure that those gears would be very precisely aligned with whatever the original design was. Because obviously, if we make a mistake there, then you're going to have gears that are going to start to grind, and they're going to start to mesh incorrectly. The mount won't be happy, and our work will be wasted. And just so I'm just going to recap sort of like how this works. So if you push the unit in and you're looking at it down, you see here that the gears are sticking out from sort of behind the plate. So this whole plate fits into the mount, and then these gears mesh and grab into the gears that are waiting for them in the mount, and you attach it and you lock it in place, and then both of your motors are essentially locked in, connected to their gears and ready to go. And both of the deck motor's hole was enlarged to match the motor, and then are coming from below, so we have a perfect mechanical fit for our mount here. The other problem we had to think about was the control box itself. So the original EM200 had its drive electronics mounted on the side of the mount. So there was a little box that was there on top of the holes where the gears went in, and the controller for the EQ Star controller was basically mounted in exactly the same location using a special 3D printed adapter, which basically remounted or realigned the screw holes, because the EQ Star Pro controller is bigger than the old EM200 controller, but essentially it provides a solid mechanical binding to connect the controller to the mount. And I want a special shout out to Jeff Booth for custom adapter and the 5 or so prototypes that he had to do to get that adapter to fit properly and to work. But the goal is that we have the adapter, it's on, it's secure, and we're not going to allow wasps, flies, or other things to get in there and cause problems. So this is what the mount looks like now before and after. So here, this is the original controller here. You can see it has something called USD. I'm not quite sure what that stands for, but it's a USD motor drive system, and this is the original Takahashi item from 2001 or early 2000s. This is the new box. It's a little bit larger and it's a little bit taller than the original box, but it doesn't look that much different. It's nicely finished, and you probably wouldn't notice it in the dark. So after some experimentation and assembly, we were able to put it all together again, and here are the results. As you can see, the mount is able to track and return. It's a reasonably good go-to performance there. It doesn't have to go super fast, it just has to be accurate, and its accuracy was actually quite good. I was able to connect it directly to a ZWO Astro box there to help with the controlling, and an auto guider. So I was able to test all of those things over the summer and passed with flying colors. So I was very pleased that we were able to get this mount to work properly. So where are we now? The EM200 is no longer a boat anchor. We've got an attractive heavy-duty surveyor-style tripod with these beautiful mahogany legs. The go-to system works well. There's a little hiccup. I noticed that it tends to hesitate and then resume when it's on a long slew, but it doesn't seem to prevent it from getting to where it's going. And with any luck, we'll have this available for sale sometime in the spring. We're just trying to make sure that the telescope is fully tested and validated before we put it on the market, so that we're able to use that, able to deliver hopefully a premium package to some lucky astrophotographer somewhere. The work that's been happening here is just to identify and to get those required adapters to allow the cameras to be attached to the scope. That's really what we're waiting for now. So once we have those adapters, we'll be able to take some test photos and hopefully prove that we've got a really, really good looking mount that will give us quality experience that people can be fun, can enjoy. So we've given new life to an old mount. We're hoping that this FSQ 106N refractor can be put in the hands of a serious astrophotographer, and whatever funds we're able to raise from the sale will be used to fund other improvements at the CAO. This year we're looking at upgrading our power mounts, which are used for our main telescopes there. They're both in need of electronics and hardware updates that need to be done. The main scope there has been used for about 25 years without an upgrade, so it's reaching that. We have a new initiative for a spectroheliograph and also a science camera program. So we're hoping to take whatever funds we can raise through the asset management process and start to put them into some other initiatives that'll benefit our members and and astronomy in general as much as possible, rather than having things sitting around not seeing starlight. So I just wanted to thank again Jeff Booth for this work on this, and other people that provided me with some consulting and help on it, and look forward to hearing some questions from the audience here. If you have any questions or observations, happy to hear it. Thank you.
Great to get this old beauty back up and running after all these years. And hopefully we'll find it a really, really good home. Do we have any questions for Denis?
Boat anchors make terrible telescopes. And that's it.
All right, then. Thank you very much. Thank you very much to both of our presenters tonight. So we don't have our usual announcements this evening because we're coming up on the holiday season and things generally quiet down. Just a few things of note very briefly. We do have two events going on at the DDO. December 6th is DDO Astronomy Family Night. The Blue Marble is the discussion topic. And then on December 12th is DDO Speakers Night. Atmospheric processes on Titan in the context of the Dragonfly mission. The speaker that night is Elisa Dong. Details for both events can be found in the events section on our website. Our next recreational astronomy night. Oh, sorry, go ahead.
From Lewis R. He wondered, how long did the rebuild take?
Denis, go ahead.
Months altogether from beginning to end. So a lot of stops and starts in there, Lewis, because, you know, like I say, first we had to sort of go, wow, look at this thing. And then we moved it up to the CAO. We had a big work party in the spring where we sort of plugged it in and sort of assessed things and tried to figure things out. I took the control box apart to see if it was just a simple wiring problem or something like that, and was defeated. And then the research began. So from the beginning of where we picked up the telescope to the point where we had our successful star test with the mount, it was about probably about 6 months altogether. But in terms of the specific steps, each specific step didn't take that long. But yeah, it's especially like I think I was implying there is like if you have a common mount like a CG5 or a Polaris GP, the aftermarket kits are plug and play. You just go and pick one you like and you just plug it in and it works. But for something like that mount with such a small footprint in the market, it really did require a bit more research. I hope that answers your question.
Briggs has a sort of question comment. He wondered, you mentioned a spectroheliograph.
So the spectroheliograph initiative is something that we have your Toronto Centre Council has just approved to obtain spectroheliographs both for the CAO, for the Solar Observing Program, and also for the DDO to help with their solar outreach programs. And for those of you that don't know, a spectroheliograph is a specialized tool that can be used with a common refractor to allow you to take really, really beautiful, detailed pictures of very precise wavelengths of the sun. So think of the best H-alpha photograph that you've ever been able to see, and you can do that with a crappy department store telescope with this tool. So the center has ordered 2 of them. I think we're investing about $1,500 in that, and we're hoping to put them to use both for daytime programs at the CAO as well as for sun fun days at the DDO. And we're looking forward to having those probably up and running in the spring.
Okay. If there are no other questions or comments,
Yep, that's it.
wonderful. So, as I was saying, our next recreational astronomy night is January 7th. We'll have the details of what's going on for that night as soon as we can up on the website. And now that brings us to an end of our recreational astronomy night. Coming up in a few moments, we're going to take a brief break. And for those of you who will be joining us for our annual meeting, you've already got the Zoom links. They were sent to you when you registered for the meeting. Just a reminder, we need 25 bodies for this meeting to make a quorum. So if you signed up, please join us. For those of you who will not be joining us at our annual meeting, I'd like to thank you very much for joining us. Please follow us on all the forms of social media. And on behalf of the Toronto Centre, I'd like to wish you and yours a very merry solstice and a happy perihelion. Thank you very much and have a good evening.